Hi, welcome to the first maths lesson. Today we're going to be looking at addition. We're going to be looking at finding one more and also the part whole model. Hopefully you've had a look at the introduction to Maths Masters and downloaded the place value counters in the base 10, and hopefully you've had a chance to have a look at the counting section as well. Unfortunately, because it is being streamed and it's for children, I've decided to do a pre-recorded session, but I'm just going to miss that chance to sort of talk to you about your maths and ask you questions and get some feedback from you. So what I'd love you to do is to share some photographs of any work you've done, share it on Twitter with hashtag MathsMasters or hashtag Marvellous Maths Masters, and I can have a look at that and I can see the approaches you've used and share some of your approaches in the next session. In the description section there are some resources for you. There's some activities to do based on today's lesson. There is a tens frame that is going to be useful for today's session, and there is also a list of key instant recall facts, the curves. And I'm going to do another clip at another stage to just explain what those are. And they're going to be really useful for you. So if you want to pause it and get those, do that now. So just to recap some of the things from the counting session, some of the vocabulary that's going to be useful for today is that cardinality, that counting objects and knowing that the final number that you count represents the group. So 1, 2, 3, 4, 5, 6. There are 6 apples there. 6 represents how many apples there are there in total. Also, subitizing is where we recognise how many make up the set without having to actually count them individually. We just recognise there are 5 there. So that's really helpful for us. Some of the language that we looked at in the counting session is looking at the total, how many apples we had in total, how many dots there are altogether. Today we're going to be moving on and looking at more. We're going to be looking at combining. Addition is combining groups together, adding them together, and we're also going to be looking at using the symbol for addition. Okay, so we don't have to keep writing it out. I'm going to be moving a lot quicker than you normally would work through addition in school, because addition will be built up over many years, lots of little small steps, lots of chance to practice, some real life problems, some reasoning using lots of different examples and resources, applying it to different contexts. But here, as this is aimed at Key Stage 2, I'm building up in small steps but recapping the learning from Key Stage 1, so to sort of cover any gaps and so to help children practice. If you feel that you find something particularly difficult and think you need more practice at it, stay working on that video and do lots of practice, and don't go on to the next day's session until you're comfortable and you feel expert at what you're working on. There's no rush. Whatever you do in the early stages will help you pick things up, make things a lot easier, and help you pick things up a lot more quickly later on. Okay, so the first one we're going to look at is finding one more. Now, in the activity section, there's some activities looking at finding one more, and they go from A, B to C, so they get more progressively challenging. So have a go at those. You can use the tens frame to find one more. So we can have a tens frame like that, but we can also have a tens frame, you can cut it in half if you want, and just like we were saying in the counting session, where we looked at one-to-one correspondence, where you physically move the objects, you can line them up and children can count them in that way. So if we have 3, we can get the children, or you can get yourself, get 3 objects. I've got little Lego people, and I can line them up. I know there's 3 by either subitizing, know there's 3 there, or I can also count them and know that the last number I got to, 1, 2, 3, is 3. So that's how many are in the set altogether. And I can add one more. 1 more than 3 is 4, or I can recount to check that there's 4 there. Now, whenever I'm doing mental maths, sometimes I find it really helpful to do a jotting. So here, I knew there was 3 to begin with. I added on one more there, and it's 3 and 1 more is equal to 4. So say that sentence to yourself. Make this number sentence and say it: 3 add 1 more is equal to 4. And this symbol here means equal to. We can do the same again. We can use 4 counters. And again, I've just been doing this, and I put a little jotting: 4, add 1 more, and 4, add 1 more is equal to 5. Or I can recount them to find out how many are there now. On the sheet you'll find the B section is 2-digit numbers, and the C section goes on to bigger numbers. So 79 add 1. If you know our counting system, our number system, you can count on from 79, adding 1. Or if you think about it, if you want to use base 10, 79 add 1 is going to make 10 now. We can't put 10 in the ones section here, so that 10 makes another 10. So 7 add another 10 is 8 tens, and 0 ones make 80. There's a brilliant resource online that I've added in the description, a place value counter that you can check your answers to those questions as well. So have a go at doing that. Now the next thing I'd like to have us to talk about is equality of numbers. And numbers can be made up of other numbers. So there are other sets of numbers within numbers. So if we were looking at, in the counting section, at the 8-dot dice, and 8 can be made up of other sets of numbers. So 8 can be made up of 4 and 4. If we have 4 and 4 and we can combine them together, it still makes 8. 1 and 7 makes 8 is equal to 8. 2 and 6 makes 8 is equal to 8. And this is called equality, where numbers are equal to another number. What I'd like to do is pause this now and see how many ways you can find of making 8. Now try and work systematically, and in a moment we'll have a look at those different ways. Okay, so I've had a go at finding the different ways of making 8. And I tried to work systematically. 8 and 0 makes 8. I knew that 0 and 8 also makes 8 because it doesn't matter what order you do addition in, it can be any order. Then I worked down 7 and 1 makes 8, so 1 and 7 does, 6 and 2, 2 and 6, 5 and 3 is equal to 8, 3 and 5 is equal to 8, and 4 and 4 is equal to 8. Okay, did anybody do that though, using 3 different ways of making 8? Because you could have had 2 add 3 add 3 is equal to 8. Could you do it using 4 ways of making 8? 1 add 2 add 4 add 1 is equal to 8. So there's lots of different ways you can combine numbers to make another number. One way of combining numbers to make another number is something called the part-whole model. And we're going to look at using the part-whole model today. So here we've got 8 counters, 8 dots, and they can be made by putting together, combining 5 and 3. So what is the whole in the part-whole model? Well, the whole is how many you've got all together, the total. And the parts are what you combine together. The parts make up the whole. And here you can see 5 and 3, when they're combined together, make that whole one. In school we can show this in lots of different ways, or at home we can use Numicon, cubes and number line. So we're going to have a look at creating a part-whole model to make 8. So what I'd like you to do is see if you can create a part-whole model to make 8. Have a go now. Okay, so hopefully you've had a go at making a part-whole model. There's the whole, and it's 8. So we can have it made up of 2 equal parts. So you might have had 8 made up of 5 and 3. You might have the whole here, this way, and the parts. We've got 8. You can have it made up of 1 and 7. Or we can have 8 as our whole, and we might have it made up of 3. Equal parts, not equal parts, sorry, 3 parts to make 8 altogether. So this is our whole, these are our parts, okay. You can use the part whole model to make little stories. So I could have 5 children went to the park. 2 more children joined them. How many altogether? How many combined? If 5 and 2 are the part and we combine them to make the whole, how many have we got altogether? Well, we've got 5, 6, 7. So we can draw them in there. To make 7, okay? And if we want to do little jottings to the side, we've got 5 and 2 and 7. 5 and 2 is equal to 7. You can do this physically with objects. You can have, if you were trying to find ways of making 5, then you could have 3 there. And 2 here, and you can actually physically combine them. Does that make 5? Or you could start with your 5 and think, okay, I can make 1 and 4, or I could make 2 and 3. Different ways of making 5 using the part whole model. You can also use the part whole model to find missing parts. So if we have 6 sweets is the whole. What are the parts? So if I had 3 sweets, I was given some more sweets. How many sweets was I given? Because I know that the whole sweets I had given, what I had all together at the end, was 6. Started off with 3, how many was I given? So you can work out 3 and look here, 3 there, so there must be 3 here. Or start at 3 and count on 3, 4, 5, 6. Okay, in the activities section, there's some activities you can do using the part whole model. Have a go at those, share your approaches with me, ask me any questions. Good luck with that, and I'll see you tomorrow for the next session. Goodbye.